Today we are going to talk about an agent-based model that simulates evacuation during building fires. This model captures the dynamics between the fire, the building structure, and the people involved. It has been made publicly available to help researchers and policymakers better understand evacuation processes and improve safety measures in such situations. So before we start the conversation, could you please introduce yourself?
I'm Eileen Young. I'm a disaster scientist with a PhD from the University of Delaware. I'm also a technical analyst now at RAN, primarily looking at policy problems related to disasters.
So to start, can you explain the purpose, the main purpose of this model and what you were hoping to achieve with the simulation?
Yes, so I made this model as part of my thesis research, and it was coming from the analysis space that this is a really well-studied fire because there's a lot of incredibly detailed information available, in part due to the profiles of a large number of people involved that were collected over the course of several years by various graduate students and faculty at the Disaster Research Center at the University of Delaware, including maps, obituaries, and reports about where people were, in part because NIST did an analysis of the spread of the fire, so we have really granular data available about how the fire moved, and in part because the night the fire broke out, someone was filming in the nightclub for a segment on nightclub safety after a recent, at the time, fire in a Chicago nightclub. And so this is the Station Nightclub in Rhode Island, and the nightclub fire that killed 100 people. And because it's really well documented, it makes it a lot easier for different people to model it. And so there were a lot of excellent models of the fire, but a lot of them don't take into account the social factors involved in evacuation. And so some of the purpose there was to introduce social factors into analysis and make the argument that social factors should be included in all models of evacuation. And so the outcome of that is this is the best model in the world as of 2018 to describe the Station Nightclub Fire. So I think it fairly persuasively makes the argument that models are improved by including the social science.
Developing a simulation like this must come with its own challenges. So, what were the main obstacles you faced during the model's development?
Yes, so some of the problem was getting the information at a granularity that it would still run. And some of this was, instead of using the output of NIST's Fire Dynamic Simulator directly, because it has incredible detail at incredibly high granularity, I had to make a decision about what scale was useful, and then it was turned into a CSV. So less computationally intense, a lot easier to include. And some of the other factors that impacted the development were, well, one, I was not a programmer when I started this. I was a social scientist by training, and then learned the programming as part of developing it. So that was also a major hurdle, but NetLogo is fairly beginner friendly in that it has an extensive online dictionary. And then one of the major things that tripped me up was how to have the agents representing people interact with the environment, not just in terms of perceiving the threat of smoke and fire and having a preferred distance from other people, but not walking through walls. The evacuation went very smoothly before I figured out the problem of having walls be non-porous. When people can exit in literally any direction, that goes very well. It's really easy to set preferences for distance. People prefer to be farther from fire, but having an absolute limit on it, such that people can't walk through walls, was more of a challenge.
Now let's talk about the results. What are the key insights that have emerged from analyzing this model?
Yeah, so the major argument I put forward was not just that people care about other people, but that people will prioritize the safety of other people about whom they care over their own safety in many cases. And that when people do non-logical, non-rational things, like instead of proceeding towards the nearest exit, proceeding towards the opposite end of the building, that is because they care about other people. So someone not going to an exit, but going towards a dance floor that's on fire may be seeking their friend who they know is on the dance floor and trying to evacuate with that person. A lot of people, parents will generally prioritize their children over their own safe evacuation. And these are emotional decisions, but they're not opaque. They're not, you don't dismiss them as chaos. They are understandable. As I'm explaining this, it probably seems really obvious that people sometimes care about other people. But to have it included in models and to argue that it should be included in all models is somewhat novel because in general, it's hard to model feelings. It's difficult to introduce into even computational social science ways to quantify and model in a way that's replicable ways to represent these feelings. And the finding is that including feelings is and these priorities does really well at explaining behavior. It ends up matching the actual outcome of the fire incredibly well, and has a lot of explanatory power looking at evacuation broadly.
You've made your model available through comsys.net. Could you please share the main challenges you encounter when making it available to others using this platform?
I had to separate the files into the different categories to upload, but in general, it was a really straightforward process.
Looking ahead, what's next with this topic and this work? Are there any follow-up studies or further research planned in this area and based on this work?
Yeah, so actually the follow-up work I did was on the Beverly Hills Supper Club Fire in Southgate, Kentucky, 1978. The Beverly Hills Supper Club Fire introduced complexity, like it's a 17-acre building. And instead of the 465 people who were in the Station Nightclub, involved several thousand. And it also added the complexity of it's a multi-story building, so I had to model stairs, which seems fairly straightforward, but absolutely was not. and was somewhat challenging. But the Beverly Hills Supper Club fire is less studied because there's not as much data available. So some of what I had to do for that was creating the data from archival police statements, interviews, and postcards, as well as evacuation maps that were held by the Disaster Research Center and the ICoR and Tele collection. And then seeing if the evacuation principles held true in the different scale, different decade, different event. And so I wanted to build on that, to have it have more technical capabilities, like dealing with stairs, but also see if the behaviors held true. The Beverly Hills Supper Club fire also introduced, there were significantly more wait staff, as well as employees. The evacuation of the Station Nightclub Fire was over fairly quickly. It was 180 seconds total from ignition to complete engulfment. So there wasn't as much opportunity for interaction on like a conversational basis. But interviews of the Beverly Hills Supper Club Fire introduced the concept that in some cases, wait staff would help people evacuate. So I wanted to introduce some of that like directional component.
Thank you so much for sharing your insights on this, Rick.